All right. Okay, so I'm going to get started. So what we're doing for this webinar is that, second, let me go here. So there should be a tweet that went live. Yeah, so there's a tweet that that was just kind of scheduled to go out. If you guys want to partake in a raffle where we're giving out a credit pack for $100, if you like, retweet, and comment on this, what kind of coding agents you're building, or maybe not even building, but what kind of coding agents are you using um, to help you engage. Um, I'll also post the slides and the content afterwards here as well. So if you want to engage with that tweet, you'll automatically get entered into a raffle. And I believe the prize is $100 credit pack on the Together platform. So go ahead and engage if you'd like. I am gonna get started on this because there's a bunch of stuff that I wanted to cover. And if there's any questions, feel free to drop them in the chat. I would rather prefer people ask a lot of questions and we discuss as opposed to I get through all of my slides. That's less important. So what I'm really going to be talking about in maybe the next 40 minutes here is how you can build up a language model that can code, that can search for code, run code, modify code, um, and then also solve open-ended tasks end to end. So something similar to what a data scientist or a software engineer would solve in a GitHub repo. Right? And I'm going to start from the absolute basics from scratch. And then I'm going to try to build it up to see like what are the problems that the language model has, and then how do you solve it. And I'm going to try to solve as many of these problems as possible so that you get a complete picture of what these language models that are writing code for you are capable of, and what's difficult for them. Right? Okay, so I'll start off. There's three things that I'm going to take from scratch. I call them the building blocks of coding agents. The first thing is function calling. So I'll introduce function calling and what it is. So this is kind of the foundation of pretty much any agent that you'll hear about. So I'll cover that. Then I'll talk about retrieval and context, and this is pretty key. It'll solve a big problem. Um, for coding agents, executing code is also pretty important, right? So I'll talk about how you solve for that problem. 1 second, let me make my screen a little bit bigger here. Okay. Um, then I'll talk about how you can build workflows for language models. So instead of just a language model coding and running one call, you want to have more intricate, complex workflow so that it can handle more complex tasks. And then I'll end off with a example of an agent that we released actually, I believe last week or the week before that, which is a data science agent. And you can give it a data set and an end-to-end task to train a model or to explore data, and it does it iteratively, step by step. And so there's code for each one of these that I'll share that you can run during the session or after the session if you'd like. And then at the end, we can take any questions that I haven't already taken during the session as well. All right. So before we begin, I'll just introduce myself. My name is Zan. I'm an engineer at Together. I work on the DevRel team. I'm pretty passionate about AI. I've been working in the field for a while. Um, I'm also very passionate about teaching and education and open source. Um, I've put a QR code there. If I don't get to your questions during the talk, feel free to just send them to me on my social media platforms. I'd be happy to take a call with you guys or answer messages afterwards. Okay, so fundamentally, what I'm going to try to the question that I'm going to try to answer is how can you use language models to generate code? And so if you think about that umbrella statement, you're going to need to worry about language models doing file I/O. They need to be able to write to files, read from files, understand what files exist in a repo to get a better understanding of what they're working with. They also need to run code, right? There's only so much that you can do just by reading code. at some point, the code that you've written has to be ran, executed, and then you get feedback on what's right, what's wrong, whether the tests pass or not, right? So that's a critical functionality that they'll need. If you also think about it, if you want to code up a task, you kind of have to understand which parts of the repository are relevant for your task and which parts are irrelevant, right? And if you give a new code base to a person, and you look at a person who's very kind of understands the code base really well, the person that understands the code base really well knows exactly which parts of the code base are relevant to the current functionality that they're implementing. Somebody who's less aware of the current code base that they're working on might not be able to search that code base and retrieve relevant code snippets well. Right? So our language models need to have some functionality that allow it to tell it which part of a code base is relevant for the task at hand right now and what's not relevant, right? And in general, coding and software engineering and data science and these types of tasks are open-ended. So you don't just have to do all of these IO execution search tasks. In general, you have these language models, these coding agents have to be good problem solvers. Um, they need to handle open-ended problems. They need to handle, if they write code that's buggy and that won't execute, they need to be able to self-correct, and then kind of fix the code, debug the code, and then go forward, right? So it sounds very complex, but I'll try to address each one of these things, and how we can solve for these. Everything in this talk that I'm going to mention is open source. All the code that I'm going to show, the guides, blog posts, whatever, are open source. If you want to have one link that'll take you to pretty much all the code that I'm going to share here, is this link, and you can get access to that afterwards as well. Okay, so I'm going to start off from the building blocks. I'm going to start off with function calling. So if we back up and we think about how we use language models, it's pretty simple, right? You have some question, you have some prompt. This could be relevant to coding or irrelevant. You can just ask a question and then you get some answer out, right? And it's text in, text out for our purposes here. Right? So for example, you can ask it what the capital of France is, and then you get an answer out. This is pretty simple. But if you ask a slightly different question, not too much more complicated, but if I ask it, what's the weather in Paris, right? Um, it's impossible for a language model to know the answer to this, right? Because a language model has a cutoff period, and it has no access to fresh information, right? So it can't tell you what the weather in Paris is today. And depending on what day you ask this question, the weather will be different. So there's something lacking here, right? This language model is kind of frozen in time, and it can't answer current questions. What this also means is that if you have code that you're giving it, you pretty much have to put all of the code in the question in order for it to understand it or reference it. Right? If you have new code that was not in its pre-training data or fine-tuning data, then it has no idea about it. And so what we're going to need to do is we need to let the model do a little bit more than just input, output, text in, text out. Um, what we want to do is give it some tools. And this is kind of the central idea that function calling revolves around. We let the model call tools in the outside world, right? This could be calling an API. This could be, I don't know, using a calculator. This could be having access to memory or anything like that. And what this allows the model to do is, if it doesn't know the answer, or you're asking about something that is impossible for it to answer, like the weather in Paris, like we just showed, it also now has a way out, right? It has the ability to call a tool to get information or to do something, and then that something, that tool might provide it an answer, right? Or some information that can give it an answer. And so these tools give language models the ability to do actions in the real world, get information from the real world, and execute things in the real world. And that's basically the concept of tool calling. Some people call it tool use, function calling. All of those mean pretty much the same thing. And it's essentially this idea that the language model can tell you when it would like to use a function, when it would like to use a tool, and then you use the tool and you give the information back to the language model. And so I want to dive a little deeper into how this tool use concept works, because people think that it's more complicated than it actually is, right? So imagine you are working here. So this could be you yourself, the developer, or it could be client side, right? It could be your app that you're building that is interfacing with the language model. And then here, this is your favorite language model. Right? This is whatever language model that you'd like to use for your app. And I'll break down function calling into 5 steps. Right? So what you do is, um, rather than just give the language model the question, so what's the weather in Paris, you also give it access to tools that it can call if it thinks it needs those tools to answer this question, right? So you give that to the language model, and then the language model goes in and says, okay, I have no idea what the answer to this question is, but I do have a tool here that I can use to get more information about this. So then what it does is it actually uses the tool, and it doesn't know how to use the tool. It'll just output the fact that it wants to use the tool, right? And so this then comes back to you, the developer, or your app. Now it's your job to actually run the tool, because you know this function. You maybe have an API, you can run this tool, and then you get the information, and then you have to feed this information back to the language model, right? So it's very step by step. The language model lets you know what it needs. You get that information, you run it. So you're going to feed that information back in. All the prior messages are being appended to this messages history that you feed back in, so that the language model gets an understanding of what the original question was, why it made a tool call, what the response to the tool call is. And now it can kind of answer the original question over here, right? Because we now gave it information. And so the last step here is it'll parse that information out, and now it has relevant context to give you the answer. Um, and this is pretty much all tool calling is, right? You can have lots and lots of tools here, and then the language model can choose to use them, or it can choose that for this question, I don't really need a tool, and so I'll just give you an answer straight up. If it does choose to make a tool call, then you have to go and execute the tool call and give it the information back. Um, and that's pretty much how tool use, function calling, tool calling works. And so if you think about what tools you need to give access to a coding language model, well, to start off, it needs to be able to read files, right? You need to give it some sort of functionality where it can tell you, oh, I need to read so and so file. If you want it to edit and write code, you also have to give it the ability to edit those files. Right? And then also you need to give it the ability to see what files exist in the environment that it's in. Right? So if you give it access to a repository, it has to ls and list all of the different files that are in that repository. So these are the kind of the bare essential tools that the language model needs access to. Let me just see if there's any questions. Yeah, so there's one question here. Let me take this one. How do we make the LLM call the right tool function by train? Yeah, so you can train it. So this is one of the things. If you here, I'm only giving it one tool to call, right? If you give it 3 tools to call, it might get confused. If you give it 15 tools to call, it might get even more confused, because every tool you give it, you kind of give it a description of when to use it and when not to use it, what information the tool will be able to give it. And so if you have lots of tools that you pass into the language model, it might get confused and might not know when to use it. Right? So the first step is you define what the tool does and you let the language model know. That's more of like a prompting solution. And then if that doesn't work, if you have way too many tools, you can actually fine tune the language model for function calling. So you give it scenarios and then you fine tune it for the correct tools that it should call depending on the input, right? So you can actually fine tune it. Yeah, so there's another question. So this is also an interesting question. What about should I wear a jacket this night in Paris? So first you need to call a tool and then use this answer again to the LLM. Yeah, that's a good point. So here, I directly asked it what the weather in Paris is, right? So it's very obvious that it needs to call this tool. But depending on how good the language model is, if you ask an indirect question, do I need to wear a jacket? It should be able to kind of understand or reason or whatever that in order to determine if the person needs a jacket, I need to know what the weather is. And therefore, I need to call this tool and then get this information. And then it has to then use this information to answer the question, right? Whether I need to wear a jacket or not. So it has to determine whether it's cold or not. So I'll show you guys code on how you execute all these steps one by one, and it'll actually be clear which part the model is calling the tool, where we're executing the tool, and then where we're feeding the information back, and then when we get the final answer out. Yeah, that's a good point. So for a lot of these models that are coming out now, for example, if you look at Claude or Gemini, they've been trained to use tools in certain scenarios. Even if you use apps like ChatGPT, if you give it a specific question, it'll call a tool, and you'll know that it's calling a tool because you can see it make a particular request, and the response will be styled differently. So I noticed this where if you ask it about the NBA, for example, it has a specific tool for the NBA, and you can try it yourself. Okay. So what I'm gonna do now, let me see if there's any more questions, and then I'll actually just go into code and show how this works. Yeah, so there's a question here. Can the AI agent control my Azure account like creating or editing a database? Um, it can. Uh, the code or the code that it needs to write or run to um, create or edit a database, it can already generate. The only thing that you have to be kind of you have to let it do is have access to your account, right? Credentials, and then you also have to be careful because if it does something like it drops a table or something and you can't reverse it, um, you don't want to be in that situation, right? So for example, in this session, all the code that I'm going to execute is going to be in a sandbox environment where if it messes up, I can just run it again, right? Um, okay, so I'll walk through these steps. If you want to follow along, you can actually just go to this code notebook. Um, I've opened it up here. So here I'm just gonna uh, show you show you the first step here. So this is a function that allows a language model to read files, right? And so really what it's doing is opening the file and then it's reading the content of the file and then just returning it to the language model. So it's a very simple function. This is the schema of the function. This is how I tell the language model how to call the function or when to call the function, right? So the description here is pretty important because that tells the language model what this tool will help it accomplish. I also tell it what it needs to tell me when calling this tool, right? So when calling this tool, it needs to tell me what file to read. So it has to give me a path, and then the tool will read the file and then give it back the contents of that file. Right? So let me zoom in a bit so people can see. Okay, so I've got my function defined, I've got my tool defined here, and I've also got the schema for this tool defined that I'll pass into the language model. And then I'll create this text file, right? And then if you run this, you'll actually create a text file over here. And then the first step now is you can instruct the language model that it has access to these external functions and it can call them if needed. And then if you ask it, read the file secret.txt and tell me what it says inside of it. And if it can't read the file, there's no way that it knows the content that's inside of it, right? So there's no way that it can hack this system. And I'm going to give it access to this read file schema that I created here. So the first thing I'm going to do is actually call the language model and see how it responds to this query of read the secret.txt. And if you run through this, you'll actually see that it's calling a tool here, and it's calling our read file function that we told it, right? So that's step two. You can extract the tool call from the model. The model is telling you, I need to run this call. I need to run this tool to successfully execute. And then the next step is for you to actually go in and run that tool for the model. Right? So you extract the tool call. If there is a function that the model wants to call, you go in and you load up the parameters that the model wants to call it with. Right? So again, the model tells you what the name of the file is that you need to call the tool on as well. So everything is in the payload here. You go in, you execute the function on the arg that the model gave you, and then you feed the response back into the model. Right? So here I'm telling it, so this is a tool, this is a tool response, and I'm telling it what tool I ran for it, this read file tool, and the response of this, right? And the response of this is just the content of the file. So it's whatever string I put into the file over here, right? This guy. And so now I appended it to the messages that the model can see. And I can kind of print out what tool I called and the content that I responded to. Right? Now the model has access to this new information. I've basically given it the output of the function, and now I can recall the model over here with this messages that's kind of growing with new information, and then see what it does. Right. So when I respond here, it can answer the question and it can kind of reveal the secret. And if it couldn't uh, tell me that it needed to read the file and I couldn't execute the read file function, then it couldn't execute this, right? So that's a complete end-to-end tool call executed. If you want to read the rest of this, you can go through. What I did is I basically put this into a chat, very simple code, and I ran it so that when you kind of chat with it, you can you can tell it to kind of chat, read files, and then understand what's in the file, and then keep on chatting with you using the information in the file. The other thing that if you want to run this code afterwards, the other thing that I did is I created a tool that allows the language model to list all the files in a directory. So if you run it here, you'll get uh, these uh, these kind of files in the Google Colab, and then you'll also get a bunch of hidden files as well. Right? And then I give it access. I give access to the model for this list files tool, and then I show an example of how it can now read the files. So you can chat with it, and then it can now read files when it needs to. And then I also give it access to a function that allows it to edit files as well. So here, uh, the edit files one is interesting because it needs to tell me what file it needs to edit, what the old string is in the file that it wants to edit, and what it wants to replace it with, right? So for example, if you give it a code file and it needs to modify a function, it has to specify the string, the lines of code that the function is defined in, and then it needs to specify what it wants to replace that old function definition or code with. So it has to tell you the replacement as well, right? The old string and the new string. And then it just goes in, opens up the file, reads it, writes to the file, and then it goes in. And so this is really where all the work is happening, right? We're going in, replacing the old string with the new string if everything else is fine, if we found the old string as well. And so those are the three tools that a very basic coding agent needs. Then what I did is I basically call the language model and I give it access to all of these tools, the ability to read a file, list all the files in a directory, and edit files. And so when you run this code, you'll actually see that you can get it now to create files. So you can get it to create this FizzBuzz Python script like this, and then you can get it to save the file as well, right? And then you can run the file and it'll actually execute here, right? And not only that, but then I also went in and then I said, okay, I want you to modify this file to only print, what was it? I think I told it to print up to 15 only. So it modifies the FizzBuzz file and then it gives me updated content, and then it saves it for now it'll print only to 1 to 15. So now when I run the file afterwards, I only get this 1 to 15. And then you can kind of keep on playing with this. You can keep on getting it to create files and then execute them to see what's inside them. And that's pretty much all it takes to build a coding agent, right? You've got code, the ability to read code, the ability to list the files that are in a directory, and the ability to edit those files as well. It's kind of a very bare bones, from scratch version of what it takes to build a coding agent. But the issue here is that if you do this, um, if you notice what you're doing, the most important thing that you're doing there is you're just appending to messages over and over again, right? You're taking the question, you're appending it to messages, you're taking a tool call, appending it to messages, you're taking the response of the tool call, and the response of the tool call is what it could be potentially very large, right? The language model might want to get an understanding of the entire code base, and so now you're appending your entire code base into this messages dictionary that's growing list, and you'll exceed the context length of whatever language model you're using really fast here. Right? And so this was one turn that I just showed you, right? We had the system message over there. We had my question to the model calling the model maybe answering, and then calling a tool, and then answering with the enriched response here, right? This is one turn. Um, and then you have to keep in mind that there's multiple turns, right? So um, the issue that you'll run into with this naive approach of, bare bones reading, writing, and understanding what files exist is that you need a very, very large context length. So the thing that is important here is that you don't really need to feed it your entire code base, right? If you have one task, you could maybe only give it the part of the code base that's relevant for it, right? And so this is what I'll go into the second part, which is retrieval and context. How do you get a language model to identify what part of the code base is relevant for a task and what part is irrelevant? So before I move on to this, let me just see if there's any questions. Yeah, so there's some questions. Yeah, passing in the schema. Let's see. Yeah, this is a good point, actually. Um, if you use the responses API, yeah, so the new API is maintain state. The problem is that for the old API, it doesn't maintain state, right? So what that means is if every call you make, it kind of has to have the entire payload, the entire history of what's happened, and then the incremental what's going to happen next, right? Um, and so that's a limitation of the old API. Okay, so now I'm going to talk a little bit about code retrieval. And the fundamental problem that this solves is it gives the language model one more thing that it can do, right? Instead of just reading in the entire code base and then trying to edit and solve a problem with it, you give it the ability to read only the part of the code base that it needs to. Um, and so this is a pretty interesting problem. How do you identify what's relevant? How do you get it to read only that? And a lot of the tools that we're using every day, like Cursor, Windsurf, and things like that, are already solving this, right? And I'll show you. So here, we really only want to give the language model code that it needs access to. We don't want to dump in the entire code base to it. And so here, we have some question for the language model. We know that some code is relevant for this question. So maybe we wanted to re-implement some function. So it definitely needs to see the function and the code around it. So we just give it access to that file or that snippet of a file so that it can give us a response. And this is just another way to say that we want to do RAG over a code base. Right? A code base could be millions and millions of lines of code, and we only want to extract out the chunks of a code base, the functions or the methods in a code base that are relevant for the language model. And that's exactly what retrieval augmented generation is, right? I'm retrieving the relevant code from my code base, and then I'm stuffing it into the context of the language model so that the response could be more relevant. Another way to see this is if I have my code base here, so this is a very simple code base, but imagine this is a complex code base. Um, and I tell the language model that it has to write some function in the mystring.py file, right? So then supposedly, let's say the only thing that this depends on is the script itself, right? You have to find a way to identify that this prompt only depends on this file, and so now you only pass in this file into the context of the language model. And this is a pretty hard task because people usually don't. People are people underspecify in their prompts. If you ever chatted with Cursor or these tools, you're not going to tell it exactly what it needs to do. You want it to kind of understand, and that understanding part is quite difficult. Here, I've actually listed out the name of the file. Um, Most of the times, I'm not going to list out the name of the file, right? I'm just going to give it access to my entire code base, and I'm just going to ask it to write a function in the place of another function or replace a function, right? So you kind of have to read between the lines in terms of what functionality the user wants you to accomplish and which part of the code base they're actually referring to. Right? One really, really simple way that you can solve this task of identifying which code is relevant is is how Cursor does it, right? Or a lot of these coding tools. You can literally get the user to highlight things, right? So in this example, the user highlights a part of their code and then asks, explain this code. Right? Explain this code is a prompt that is not specific at all. If I asked you to kind of identify what part of the code I was referring to, there's no way that you could do that. The only way that you know is because I highlighted it, right? So how do you know what's relevant? You can literally just ask the user, and a lot of these tools use this extensively. But you can't do this. You can't always do this, right? And even for this particular code, to understand what this code is doing, I could just have, let's say I have a function, and this function just calls another function, right? And so in that case, the context that's highlighted is not enough. It would still need to identify what this other function is doing and read that into the context of the language model so that the language model can explain it, right? So this is a first step, but it's not the final solution. The other thing that you can also do is you can do a text-based search. So whatever code you have the user highlighted, you can do a text-based search based on the text that's mentioned here and retrieve other parts of the code base and also pass it into the language model call. And so here, if you've used these tools, you'll notice that they actually do text search as well. Um, they often will just do a grep to look for specific keywords in your code base. And so when they do that, they're basically trying to identify keywords in the query, and they're trying to extract out kind of those keywords that are repeated in anywhere in your code base. Right? Um, and so they use this functionality as well. The problem with this functionality is that it's very keyword specific. It'll extract out the function that you need, and then all the times the function is called as well, right? So here it messes up because it extracts out not the actual kind of definition of this nested list, but kind of something that uses a keyword that fooled it, right? So really, what you want these models to do is understand the query, the content of the query, and then extract out the part of the code base that is specifically addressing that query. So maybe the function or the class that can solve for it. And so this is more of a semantic search functionality where you can give it your entire code base. I'm just going to see if there's questions here. Yeah, this is a good question. This is a good point. Um, So in my code, I'm literally just reading the contents of the file. I'm opening it and reading the contents of the file, right? Um, and this person is saying that you can actually use a unified diff to apply changes to a file. This is a good point. And even if you look at the Aider bench, Aider polyglot, I think they published a blog post. I can't remember, I think it was about a year ago now, where they showed that if you have a coding agent that operates in diffs, it is actually much more accurate than if you have a coding agent that does what I showed earlier. It's a little easier to understand what I did earlier because it's kind of going in and modifying things um, one by one. But they argued that if you give it a unified diff, it functions better. And I also remember one of the reasons they said that that was the case was because a lot of these language models are pre-trained on a bunch of GitHub data, and GitHub has a lot of diffs. So they see a lot of that in their pre-training data, and they're more familiar with that. Um, I'm not sure if that's true, but it made sense to me. Yeah, there's another question here. What do you think about the idea that we use language models to describe all code units, methods, classes in human language, and then we use that description for semantic search? Yeah, this is a good point. I don't think it's necessary. And I don't think it's what a lot of these companies are using. A lot of these companies are using code retrieval models that you can embed chunks of code, and then you can give it queries or similar code, and it can retrieve relevant code. Um, and that works fairly well. So I'll talk a little bit about code retrieval models. So you take your code base, you chunk it. You can chunk it into different functions, different classes, or different files and chunks within those files. And then you have your code embedding model, and you can put the embeddings into a vector database if you've achieved a large enough scale. And then the prompt from the user comes in, and you hit this vector database over here. Right? And so some part of the code base that's chunked into the vector database will be relevant, and then you extract those chunks out and you stuff them into the language model prompt, and then the language model can kind of respond. Right? And so this is one way to embed code and then extract out the top relevant code. And so if you want to think about how code embedding models work, really what they're doing is they're taking your code and they're kind of passing it through this embedding model that's generating vectors, right? Each vector is one chunk, and you define what one chunk is. Right? And the idea behind this is that similar code pieces will be closer together and dissimilar code pieces will be farther apart, right? So in this visual, if you have kind of some concept of a cat and a dog, they might be closer together versus a banana and a cat might be further apart. So the actual vector distance will be further apart. Right? And so typically how I think about this how I understand this is if you're looking at books in a library, similar books are closer together physically in the library. Dissimilar books are further apart because of the actual classification system that is used to place those books in the library, right? So really what I want to do is take my entire code base and structure it and place it into a library where similar functions are closer together, similar parts of the code base are closer together, and then I can retrieve those parts. Right? And so if you think more concretely about what these code embedding vectors look like, there's code here that I wrote, but basically I asked the language model to give me an implementation of bubble sort, and then I passed it through a code embedding model. I used an open source one. It's the one from Alibaba. It's a modern BERT fine tune, and I asked it to vectorize it. And then here I'm just visualizing the vector, which is 768 dimensional as a barcode. I thresholded the vector and I just plotted it out so that you can see what it looks like. And then I asked another language model to implement a heap sort implementation. And this is what the vector of that code looks like. Right? So I took that entire code snippet, I passed it into a vector, an embedding model, and it generated this vector for me. And then I gave it a third code snippet, which was a Pygame implementation of the game Snake. Right? And so these three vectors, because heap sort is much more similar to bubble sort than it is to a Pygame implementation of Snake, I should be able to kind of see some of the similarities between these vectors. And if you squint your eye, you'll see that the black lines co-occur with the black lines in these two, but they don't over here, right? You kind of see different patterns in the bottom. But it's a little bit difficult. So then what I actually did is I went in and I calculated the distances between the bubble sort vector, the heap sort vector, and that was zero point 0.2, 0.22, let's say. And then the bubble sort and the Pygame vector, uh, this guy and this guy was actually around zero point 0.5. And then the heap sort and the pygame uh, vectors were zero point 0.5 as well, right? So notice how code that is irrelevant or dissimilar has a higher distance. The vectors have a higher distance. Code that is more similar, bubble sort and heap sort, the vector distance is actually smaller. Right? So those vectors are closer together in embedding space. And if you want to see this in action, if you want to run it, you want to modify it yourself, I have a code notebook here that you can also run as well. Right? So this is the actual code. I've just printed it out here. Um, second. So I asked the language model to generate bubble sort, heap sort, pygame snake, and then I use this modern BERT base fine tune to generate the vectors. The dimensions are 768 dimensional. Uh, and then I went in and I just created this visual. So you can kind of play around with it. You can modify it um, and see how it works, right? And then this is where I actually calculated the vector distance between them. So this is a good question. This person asks, are constant sized inputs necessary for embedding models because functions are not the same size? Constant sized inputs are not necessary. So if you look at this code, this is the snake game implementation. The number of tokens in this is very different from the heap sort implementation, right? This. Um, so the only thing that matters is that your code snippet has to be smaller than, I believe for modern BERT, it's about 8,000 tokens. It has to be smaller than that maximum context length of the model. Right? That's all that matters. So you can have anywhere up to that number of tokens. That's a good point. So another question here, does it do the search vector all the time a query comes in? No, it doesn't always search it. This is the other thing that when I use a lot of these coding agents, sometimes they will trigger a search. Other times, if you've specified which files are relevant, if the user tells the model or if the user tells the tool what files are relevant, it won't trigger a search. Um, it'll just use those user defined similarity. Other times, if the code base is too large, it'll just automatically trigger a grep first. So it'll do a text-based search first, and if that fails, then it'll go to a semantic search. So it's kind of interesting how they've tiered the searches so that you get really fast and quick searches first, and then if it's a really hard problem, then they'll go to semantic search. So there's another question here. Let's take this. This shows that similar code is grouped together with the embedding models, but the question is, what is the distance between word sorting algorithm and those code snippets? Yeah, that's a good point because the input query is not going to be a code snippet. It could be a code snippet. If the person highlights it, then you could literally turn that highlighted code into a query, and you can turn that into a query vector, and you can kind of uh, retrieve from your vector database using that query vector. But let's imagine the query is just a prompt, right? Write me a sorting algorithm, or rewrite my sorting algorithms in the code base or something like that, right? So now you have to kind of take that query, vectorize it, and then calculate the distance between that query and the actual code of the sorting algorithms. Right? That's a good point. Okay. Uh, I'm running out of time, so I want to move a little bit quickly. So the next problem that I want to solve is that these language models still can't run code, right? They can search for code, they can edit files, read files, but they can't really run code. And if you can't run code, that means that you don't know if the code you're writing is passing tests, if you're going to get execution errors when somebody does run it, and you can't even optimize the code, right? So if you can't run it, you can't understand kind of the memory footprint, the runtime complexity of the algorithm. You can kind of do calculations, but it would be good to be able to run it and get an understanding and do experiments on it, right? So the solution to this is to give the language model ability to execute code. And so here we're proposing kind of giving it one more thing, right? The ability to run code that it wants to, right? And so here it can use this tool now, this functionality to write code, run it, and then get feedback on how it needs to improve it. Right? And then it can keep on doing this until you meet some sort of termination condition. And so for this, we have a kind of a tool called Together Code Interpreter, where you ask the language model to solve a coding problem. It writes code, and then you give it to Together Code Interpreter, which is essentially a sandbox environment where you can send Python snippets, and it will run the code, and it will give you back feedback or execution or whatever the output of that code running was. It'll give that back to the language model. And now the language model can choose to run more code and then get more feedback, run more code. So it can kind of go in this loop, or it can choose to terminate, right? And you define what this termination condition is. Maybe it passing the test is a termination condition, or running within a predefined time is a termination condition. And it can kind of go back and forth in this loop and iterate. And so, if you want to get an understanding of how this works, there's a third notebook that that's over here. And this will take you through kind of using Together Code Interpreter, everything from running like a simple hello world command and kind of calling the code interpreter and then getting it to output this to your terminal and then printing it out. You can also do much more complicated things, right? You can get it to persist variables and then reuse them. So here in my first code run, I have a snippet that just defines a variable, x equals 42, and then I reconnect to it, and then I ask it to print out the value of the variable, so it can persist state between different connections to the session, and you can print it out. You can also get it to do all sorts of data sciencey calculations, right? So you can get it to do matrix multiplications. You can get it to calculate the eigenvalues of a matrix. Together Code Interpreter comes pre-installed with pretty much all of the good data science and data analysis libraries that you'll need. The coolest thing that you can do with this is that you can upload files and get it to do data analysis on those files as well, as long as you give it code to do that analysis, right? So one interesting thing that I'll show you here is you can upload a CSV file, and then you can give it code that trains a model on that data in that CSV file, and then you can plot out the kind of line of best fit. So here I generate a bunch of random data, and then I turn it into a CSV file, and then I pass in this encoded CSV file uh, to Together Code Interpreter, and then I also give it code that it uses to train the model. So Together Code Interpreter is going to run this code against this file, and it also plots out the line of best fit. So now when you execute this, you can actually kind of get the responses. It'll give you back images as well, and you can kind of render them. Right? So this is your data, and this is the plot from Together Code Interpreter. And so right now I'm writing the code myself, but really what you want to do is give the language model the ability to write code and then define Together Code Interpreter as one of the tools that it can call to run that code and get feedback on that. And so that's exactly what I did. So one of the things that I did is in one of our projects, we gave it the ability to run code and get feedback. And what that allows you to do is if it wrote code that's buggy, it'll try to run the code, it'll get the error back, and then it'll try to edit and solve it. Um, and so here, this is kind of, we're getting closer to an end state where we have more of these autonomous workflows where the language model can write code, fix errors, and then rerun the code. And this is what you really need to solve real world problems, recover from failed attempts, debug. And so here I wanted to show you guys an example. I'll skip over these LLM workflows for agents, just in the interest of time, because I really want to show you this data science agent that we worked on. I'll give you the slides later if you want to look over it. There's more resources in that, but I want to go to this example that shows you kind of what you can accomplish with this. So this is a code notebook that we put out, and we're going to release more stuff around this soon. But if you think about what a data scientist does, this is kind of a very complex kind of loop, right? You gather data, clean data, engineer features, select models, do hyperparameter optimization. You can train multiple models, see which ones work, deploy them into production, monitor them to see whether there's data drift or not, and then you improve it. And you can kind of keep on going about this, right? Um, if you simplify this slightly, let's say you take a data analysis task, right? Here, you have some question that you want to answer with data. You can explore the data, do exploratory data analysis, train a model on it, and then understand the responses from that model, right? Understand the responses of that analysis. If you want to do this, you can actually do this with all the tools that I've talked about, right? The ability to edit files, the ability to read code, um, to search for relevant code, and then also the ability to execute code and get feedback. And so that's exactly what we did. We actually wrote a data science agent from scratch. This is work that the agents team at Together did. It was a lot of fun working on this. So you give a language model a question, and then you build out this iterative workflow where it can plan out what it needs to do. It produces code, and then you take that code, you give it to Together Code Interpreter, and you give the output of that code as an observation back to the language model. And now the language model can decide. I now have the output for the code that was ran. I can either choose to terminate and finish, or I can take the next step, right? I can plan to do something else, and it can keep on going until it determines that the question is answered and it terminates. And so this very simple workflow that I can kind of plot out here can do very complex data science tasks. And so I want to take you through this notebook as the last step here before we end. So the notebook is behind this QR code, and you can look at it. But here, let me just scroll all the way up. So you can read through this, but uh, in this case, I'm gonna run all of these. I'll skip to the part that's interesting here. A lot of this is kind of boilerplate setting up the agent. This is where the agent is defined, right? So here, really all the agent is doing is planning and then writing code. I'm trying to see where it wrote code. So I'm parsing out the code, and then I'm calling Together Code Interpreter to run that code. I get the responses. So here, I parse out the code, and I take its thinking process and the action output. So the action output is code. And then we can run Together Code Interpreter to actually run the action output here. And I get the execution results, and then I loop through the execution results to see if there's errors, if there's images that were printed out, and then I give it back to the language model to decide what the next steps are. And then I just keep on doing this. This is basically wrapped in this while loop, where as long as I'm below a certain budget count, I can keep on going. And so when you run this, you can actually get it to execute very interesting workflows. So let's see this. The first one here, I'm just asking it to load in the iris dataset and create a scatter plot. And so first it thinks about what it needs to do. It writes code. I then run that code over here. When I run that code, I get text response and an image response, this guy that I printed out here. And then I give it back to the language model. Now the language model decides, oh, I need to do something else next. I'm going to write code to do that thing. I take that code and I run it and I get the result. And then I give it back to the language model. And I just kind of iteratively going until the language model chooses to terminate or it hits the budget boundary. Right? And so this is quite simple. The iris dataset is very well understood. And it can do this analysis for you, and it can generate these plots for you. Right? The other cool thing that you can do is so you can see the second example, but I'll show you the third one, which is a little bit more interesting, where here I actually give it this data file, right? So here I've got test this train and test CSV. I'm going to ask it to perform EDA on this test train CSV file. And so here it's going to find the file. It's going to start a Together code interpreter session with that file, and then the language model is going to take over. Right? So first, it needs to load the file in. So it writes the code to load the file in, and then it says, okay, I need to understand its structure. So it's using these basic pandas functionality to understand the shape, the number of columns, read out the schema over here. And then it says, what do I need to do next, right? So it's kind of going about it as I would one by one as a data scientist. Right? And then it starts to visualize it. So it's doing EDA on your data set. So this is one prompt, and it's just taking it step by step, and you can actually walk through it. And so now it's visualizing the different features. This data set is the Titanic data set. If people are aware of this, it's a very popular data set from data science. And it just keeps on going. Right? Because this task is a bit open-ended, the termination condition is not too clear. It can kind of keep on doing EDA and keep on finding interesting things. If you give it a more close-ended task, like train a model to classify on this data, then it'll actually train the model, and then that'll be the termination condition. So here it'll keep on doing EDA until it's satisfied, and then it'll get to the final answer and kind of summarize everything that it did for you. And so all that we're using here is pretty much the combination of a lot of the kind of building blocks that I talked about. So here, yeah, so that's pretty much all that I had. We're at time, but I'll take some of these questions, and then we can end it off here. There's one question here. This shows that similar code is. Oh, this is an old question. My bad. There's another question. Here, the context is continuously growing, right? Or is the old context discarded at some point or compressed? Yeah, here the context is growing. So you can add a functionality in the agent where you summarize. If you give it a really high iteration count, so my max iteration count was 20. If you set it to 100, you might run into context length issues. Right? So there, what we implemented is more you summarize the functionality and then you feed it in rather than dumping the entire response. And then if you run into context length issues, even with that, you can get it to summarize the last 5 to 10, the oldest 5 to 10 responses, and then you can kind of throw that out of your growing history and replace it with that summary. So that's one way to deal with the context length issues. Thanks, everybody. I'll keep on taking questions here, and then I'll end the session. So if people have questions, just feel free to throw them in the chat. But if for people that are leaving, thank you so much for dropping by. The talk and the slides will be made available afterwards. And the question: what can I do if the conversation is too big for the context of the model? Yeah, so that gets to the previous question that I just answered. Okay. The other thing that I'll do, if you guys have questions that I didn't get to during the session, feel free to ping me afterwards on my socials, and I'll be happy to talk with you guys. Okay, thanks everybody. Uh, we are hiring as well, so if you'd like, you can apply. You can also join our developer community on Discord and engage with us. Thanks so much, folks. Hope this was useful, and we're going to be running a lot more of these, so keep an eye out for the next session. Thanks so much for dropping by. Thank you for your time.